Okay, I'm going to review how to do number 10 and number 19. Number 10 says a reaction is performed in a vessel attached to a closed tube manometer. So let's get clear about what a manometer looks like. So here is the reaction vessel. Okay, the gas is being produced, creating pressure. That pressure pushes down on mercury in this U-tube, which is a manometer, right? And depending on how much the pressure gets, how large the pressure is, it will push the mercury up higher or lower than the atmospheric pressure. Okay, so before the reaction, the level of mercury in the two sides of the manometer were the same height. So imagine like this. As the reaction proceeds, a gas is produced. By the end of the reaction, the height of the mercury column on the vacuum side has risen 31.79 centimeters, and the height on the side of the manometer connected to the flask has fallen by the same amount. So both of these are 31.79 centimeters. Okay, so let's take a look at how we would solve it. Okay, so it says at the end of the reaction, so what we have here is both of these together add up to 63.58. It's moved up 31.79 and down 31.79 centimeters. I add those together and I get 63.58 centimeters. I simply convert those to torrs and I get 635.8 torr. Now the rest of 11 through 13 is just converting units of pressure. Okay, so let's take a look at number 19. Okay, so number 19 says, what is the density of xenon gas at 750 kPa and 25 degrees C? So let's get clear about what density is. I keep doing that. So density is grams divided by liters. Okay? And so I can make liters 1 in the Pivner equation. And so if volume is 1 liter, grams is what I'm trying to find. But I also know grams, moles is grams over molar mass. So if I look at rearranging the equation, PV equals nRT, I substitute in grams over molar mass and rearrange the equation a couple times, and I end up with the grams is equal to molar mass times PV over RT. So my molar mass is 131.29 for xenon. I convert my kPa to millimeters or to ATM, and I get 7.4 ATM, so I put that in. My volume is 1 liter. I find the right R on my equation sheet for the units that I'm using, and it's 0.08206. I convert my temperature to Kelvin, it's 298. When I plug and I chug and I cancel all my units, I end up at 39.7 grams, and of course I'm putting this over 1 liter, so it's 39.7 grams per liter. Hope that helped.